In question 5, line L passes through the points A and B as shown there, right? And so you have a variety of questions to do with A and B. First question asks you to find the distance between points A and B. Well, that's just distance formula. x2 minus x1 squared plus y2 minus y1. Essentially a version of Pythagorean theorem. So it's helpful in this question, especially because we're going to be going through a whole bunch of stuff to label one of the points x1, y1, and another point x2, y2. And then that's helpful in being able to make sure that you substitute the points in correctly, especially because there's some negatives in there. The formula has some subtractions. So x2 is negative 7, and then minus, right? I'm actually going to put those in there already. Minus, and then x1 is negative 3. So you've actually got negative 7 minus negative 3, which we know is going to be negative 7 plus 3, right? Plus, and then y2 is 15, and y1 is 7. That's not so hard because those are positive numbers. All right? You're going to end up with d equals, d equals negative 7 plus 3 is going to be negative 4, and then negative 4 squared will be 16. Right? And then 15 minus 7 is going to be 8, and then 8 squared is 64. If we add those together, we get d equals the square root of 80, or in decimal form, approximately 8.9. All right. The midpoint between points A and B in question B. Well, midpoint is just the two x values sort of added together and divided by 2, right? It's the average of your x values and the average of your y values. Again, it's helpful if we have x1 and y, x1, y1, x2, y2 labeled. So this is negative 3 plus negative 7 over 2. And separately, 7 plus 15 over 2. Negative 10 over 2. 7 plus 15 is 22 over 2. And so actually, when you calculate that, you end up getting negative 5 and 11 as your 2 points, or your 2 coordinates, excuse me. Okay. It then asks you for the gradient of line L. Gradient of line L. Actually, I'm going to keep my points at the top of the page to help me out, right? So this formula is y2 minus y1 over x2 minus x1. Now, just in case they're talking about something different, right? It says, the gradient of line L. We go back to the top of the question, and we can see that sure enough, right? Line L passes through the points A and B. Yeah? So the reference that they're making there is something that I am using the correct points. Just always want to just check back and make sure. So y2 is 15, y1 is 7, and I'm looking up here while I'm working, right? x2 is negative 7 minus x1 is negative 3. I think there's a few people that made that mistake, either in the distance formula or here in the slope formula. 15 minus 7 is 8. 7 minus negative 3 is negative 7 plus 3. We already saw from the distance formula that's negative 4. And then when you divide those two, and you end up with a slope of negative 2. Slope of negative 2. So then, last but not least, line M is perpendicular to line L and passes through point A. So, So point A is negative 3, 7, right? Negative 3, 7. Find the equation of line M. All right. So if it's perpendicular, right? If it's perpendicular, then that means the slope is a negative reciprocal. So if the line L slope is negative 2, then line M slope will be the opposite sign and that fraction flipped, right? So I'm going to be sort of, it'll be 1/2, positive 1/2, because the slope of line L is -2. So I've changed the negative to a positive, and I flipped the fraction. Right? So then, once I've been able to conclude that, I would use, I mean, there's a couple of different ways to do it, but I would use y equals mx plus c as the equation that I'm going to use in order to sort of find the y-intercept. I know that I need y equals mx plus c, and I need m, and I need c. Well, I have the slope, 1/2, right? And then I know that it goes through the point A, right? I know that it goes through the point A. So I'll put -3 in for x and 7 in for y, leaving c as the variable that I can find in the equation. Multiply 1/2 by -3, get -3 over 2, right? Because when we're multiplying fractions, we multiply the top number and the top number, the bottom number and the bottom number, plus c. That's 7. I mean, if I really wanted to, I could sort of imagine this as a variable. That might help. I'm going to add the 1.5 to both sides. So I'm going to get 7 plus 1.5 equals c, and that's sort of 8.5 equals c. All right? So then ultimately my equation is 1/2 x plus 8.5. And it's possible that, say, for instance, you might have done the 8.5, 7 plus 3 over 2. You might have done it in fraction form, which 14 over 2 plus 3 over 2. We need common denominators, and then that's 17 over 2. So your equation could have been y equals 1/2 x plus 17 over 2, right? It's fine if it was in fraction form. That's also okay.